Let's take a look at this example. Okay, let me just make clear that this is 0.35 amps. Okay, so this is 0.35 amps current, and this one is 0.451 amps. Okay, other words, I can say that R1 is equal 350 milliamps. Okay, 0.35 amps is equal 350 milliamps, and I can say that this is my current IR34, because this current is going to split into two currents, and this is equal 451 milliamps. Okay, so now we have to find values of resistor R1, and we're supposed to find value of resistor R3. Okay, and also what we can find as well, let's say I total. Okay, now please keep in mind that we have over here parallel circuit. Why? Because the total current is going to split. Okay, this is my total current, I total, is going to split into four currents. Okay, because one current is going to be my IR1. Okay, another current is going to be my IR2, another current is going to be my IR3 and IR4, and all of them are going to get back together to ground, and by ground they will return to V1. So it makes these resistors connected in parallel. Okay, the total current splits into four currents and comes back on the other end and gets back to the voltage source. So how are we supposed to start solving this problem? Please notice that we have given IR1, which is equal 350 milliamps. Okay, and voltages in the parallel circuit are the same. So we have V1 is equal to VR1, this is also equal to VR2, this is also equal to VR3, this is also equal to VR4, and this is equal to 35 volts. So R1 is equal VR1 over IR1, where VR1 is equal 35 volts over IR1, which is equal 350 milliamps. Okay, so this is equal, we'll use the calculator just to practice. We have 35 divided by 350 exponent 3 negative. This is equal 100 ohms. Okay, so I have over here 100 ohms. Okay, so I found the resistance R1. Next, I'm supposed to find the resistance R3. In order to do so, I would find first the current which goes through resistor R4. Okay, so I can say that IR4 is equal VR4 over R4. VR4 we said is equal to 35 volts. Okay, 35 volts VR4 over R4, which is equal 120 ohms. So I have 35 divided by 120. This is equal 291.66 milliamps. So I have 291.66 milliamps. Okay, so this is my IR4. Okay, now if I know this current, I can find very easy this current. So IR3 is simply equal IR34 minus IR4. Okay, so this current which goes through these two resistors, okay, minus the current which goes through this resistor will give me current which goes through resistor R3, okay, because the sum of these two currents will give me this one. So I have 451 milliamps minus 291.66 milliamps. This is equal 451 exponent negative 3 minus 291.66 exponent 3 negative equals 159.34 milliamps. Okay, so this is the current which will go through resistor R3. If I know the current which goes through resistor R3, I can find the resistance of resistor R3. R3 is equal VR3 over IR3. So VR3 is equal 35 volts over 159.34 milliamps. Okay, so this is equal 35 divided by 159.34 exponent 3 negative equals 219.65 ohms. 219.65 ohms. So we can say that this is approximately 220 ohms. Okay, and also we can find total current. Okay, because we found the values of the resistors. Okay, we found R1, we found R3, so we can find total resistance. So if R total is equal 1 divided by open parenthesis 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, and this is equal 1 divided by open parenthesis 1 over R1 we found is equal 100 ohms. Okay, we have 100 ohms over here, plus 1 over R2 which is equal 560 ohms, plus 1 over R3 which is equal 220 ohms, plus 1 over R4 120 ohms. Okay, so R total is equal, I'm going to use the calculator, 1 divided by open parenthesis 1 divided by 100 plus 1 divided by 560 plus 1 divided by 220 plus 1 divided by 120 close parenthesis equals 40.54 ohms. 40.54 ohms. So now I can find I total. I total is equal voltage source, which is V1 over R total. V1 is equal 35 volts over my R total, which is equal 40.54 ohms, and this is equal 35 divided by 40.54. This is equal 863.34 milliamps. Okay, so this is my total current. Now let me find the total current in a little bit different way. So far we've found the current which goes through resistor R3, R4, okay, but basically we can use just this current, and we have this current, okay, current which goes through resistor R1. So we need to find only this current in order to verify our answer. So I'm going to find just IR2. IR2 is equal V1 over R2, which is equal 35 volts over 560 ohms. This is equal 35 divided by 560 is equal 62.5 milliamps. Okay, so I have 62.5 milliamps. And we can use KCL. KCL says that I total is also equal to IR1 plus IR2, and in our case IR34. I'm not going to use the separate currents, I'm going to use this one. So I have IR34. So I total is equal IR1 is given 350 milliamps plus IR2 we found is equal 62.5 milliamps plus IR34, which is equal 451 milliamps. Okay, use the calculator, and we have 350 exponent 3 negative plus 62.5 exponent 3 negative plus 451 exponent 3 negative. This is equal 863.5 milliamps. Okay, so now we can compare the values of the total currents. Okay, so this is the current which we got before, okay, by using Ohm's law, and this is the current which we obtain by using KCL. Okay, as you can see, these values are very close, so it means that all our answers are correct.